This time, they're using liquid nitrogen.
It's raining nitrogen.
That's pretty cool.
A pure elemental substance that's a gas at room temperature. In that form, it is odorless, colorless, and 80% of the air we breathe. Nitrogen can only be made liquid by cooling and compressing it down in frigid temperatures of minus 360 degrees. Anything warmer, and well, there it goes, right back to an expanding gas. Liquid nitrogen is dangerous because it can freeze anything in seconds, which of course begs the question why these two insist upon playing around with it.
There it goes.
They just can't help themselves.
So can we just pretty much instantly freeze anything we want to today?
Yes.
But temperatures this cold can lead to some serious fun
Let's start.
because it can quick freeze just about anything.
Oh,
First up,
We can start with some gummy candies.
soft, pliable, cute little candies.
I'm gonna just dump them in, let them boil up a little bit.
so they look like they're cooking.
Actually, when they start to slow down, that means they're closer to temperature, but
Speaking of slowing down,
yeah, ready?
Yep.
As expected. That looks like a crystal animal.
It's not gummy anymore.
You have this molecular structure that's in this crystal pattern. It's like perfectly aligned. And when it's gummy, that is free to be bent back and forth. The colder it gets, the more like glass it becomes.
And then 2 seconds after we shot this, it was gummy again.
Whatever rate you're cooling this down in the nitrogen, it's going to heat up 100 times as fast at room temperature.
All right, that's cool, but I want to break some more stuff.
What do you want to break?
I don't know, let's freeze something and break it.
We got tons of stuff over here.
how about a rose?
Probably the softest thing that we've got around here. We just drop this like normal.
Yep. See it?
Okay.
Okay.
Right here?
Yep. That's outrageous.
It broke. But to use a scientific phrase, it sort of looks gushy.
Yeah, this one was actually starting to convert back to a soft form. You can see that right when it hits, it starts to bend, and then it cracks and hits that breaking point.
Freezing stuff has its limitations, and our intrepid team soon realized that.
What we could look at now is how much things change when you contain the gas itself and heat it up,
That's gonna end badly, isn't it?
usually.
Okay.
The ability to mess with the natural state of matter is a great power.
You know how much I love things that go boom?
Yeah, this should be pretty big.
But with great power comes great responsibility.
All right, if you do the funnel, can you see the bottle?
No.
Or
Is it
so
going
we
in?
hope. Jeff is pouring supercooled liquid nitrogen, a substance that wants to be a gas at normal temperatures, into a tightly sealed container. Can you guess what will happen next?
And how much time do we have after we cap this?
I have no idea. We should have at least 15 seconds. All right.
Now we wait for me to get scared again.
With each passing moment, the liquid nitrogen in the bottle is warming up and the gas is expanding.
Did you bring any cards?
Yeah. I have some games on my phone we can play.
So we wait.
Whoa! That was cool.
Whoa, that was cool. Why do we think Galileo said the exact same thing when he looked through his first telescope?
So I have one last question. How much liquid nitrogen do we have left?
Let's see.
As our Nitro Cowboys rode off into the sunset, they decided to give us one last parting shot.
We're gonna blow something up. Let's blow
Make that parting drop.
That's perfect.
I wanna see it. Wow.
Bam.
There's no watermelon left.
A few tips for those of you trying this at home. Don't! We repeat, do not try this, even if you can get the liquid nitrogen. Even if you decide to break a watermelon. Wearing lizard, snakeskin, or crocodile might get you through a situation like this. But what is going to get you through a situation like this? The answer? Dragon skin, the ultimate fashion do when bullets are flying. This latest and what many are saying greatest protective vest is the newest generation in body armor, which compels the obvious question:
Is this bulletproof?
No, it's bullet resistant. It's bullet resistant to a certain threat level. If you exceed that threat level, then the rounds will go through.
In this case, threat level equals the type of weapon shooting at you plus distance. But how does one of these things resist and hopefully stop a bullet in its tracks? In order to find out, we first must get warped. Test number 1.
All right, so we're gonna work our way up to this, but why don't we start with the old school bulletproof vests?
First up, aramid fiber. It consists of layers of tightly woven synthetic fabric that act together like an array of tiny nets to actually catch a bullet. For testing purposes, we've taken a square sample from each vest and secured them to metal frames to act as our targets. Note for those playing at home,
Same deal?
we shot some footage with black and white cameras. They're more sensitive to light, so we can go faster. 40,000 frames a second without extra lights. And it has to be fast to catch a bullet in flight. Watch what happens to this 45 slug. Watch again. Stopped inside the fabric layers. But what happens when the vest meets a higher threat level? A .306 rifle.
Where are those?
After leaving the muzzle at more than 1,700 miles per hour, the bullet shatters the sound barrier. And the result? Clear and deadly. It goes through that vest like it was a piece of tissue paper. Unlike handgun rounds, rifle bullets are pointed and much faster.
You can overmatch anything, and that's why it's not bulletproof. It's bullet resistant for a certain threat level.
Yeah, you mentioned that earlier. This is where those smart engineers came in. They designed a single ceramic plate to join with and bolster the strength of an aramid vest. Again, a .306 rifle blast, and the bullet is stopped.
There's nothing coming out of the other side, that's for sure. It's a solid 1-inch hole.
The ceramic bolster is effective. What would happen if we fire again? The second bullet is also stopped, but our warp speed cameras capture a serious flaw in ceramic armor.
So what happened? That's like so different.
Well, what you're seeing there is you're seeing all of that nice shiny stuff is the exit of the ceramic. The real dark stuff is bits and pieces of lead. That's a piece of a bullet jacket. See, it's shiny?
Yeah. The thing that gets me most is that all this ejected material is actually moving as fast as the bullet was moving.
You don't even want to be standing next to the guy who took that round. I mean, there's shrapnel everywhere.
If I took a round and I'm standing here, you're going to catch that in your face.
Clearly, there is room for improvement, and that's where the dragon skin vest comes in.
What we did was we came up with a segmented solution that has flexibility in it that will actually wrap around the torso and take shots on the individual discs. Instead of the cracks propagating across and structurally weakening the entire system, it's isolated and localized.
This lets you get hit potentially several hundred times over the whole body and have it still withstand all those hits.
Yes, the idea is to increase the survivability of the officer or the soldier that wears it.
Let's watch the dragon do its thing. It's also covered with aramid fiber.
Where are those? Nice shot.
Even after 3 hits from a high-powered rifle, the dragon skin is intact.
Oh, it's totally different.
Yeah, what happens is the bullet is destroyed within the skin of the material you see there.
Let's compare. Both vests destroy the bullet, but only the dragon skin on the right contains the debris. Watch it once more. Even under the aramid fiber, you can see the scales that shatter the bullet. The dragon skin concept is stunningly effective.
It's easy to trigger because all you gotta do is go like that and you're done.
As long as you don't forget.
Traditionally, now is the time when we would have Jeff put on a vest and take a pot shot at him. But being hit by a bullet, even with this vest on, is like standing at home plate and getting Sammy Sosa to hit you with his best shot. In other words, Jeff just dodged a bullet.
You can smell that gunpowder in the morning.
I like it.
What is it about fireworks that reduces everyone watching to a universal language containing less than 5 words? Ooh. Ah. Wow. Cool. Run! But while enjoying fireworks is the simplest of pleasures, creating red rockets bursting in air involves complex events that you never see. Why? Because most of them are too fast, too far away, and too dangerous to be observed by the naked eye. What is amazing is all this comes from just this. For many excellent reasons, Matt Shea of Atlas Pyrovision has never tried detonating a commercial firework near ground level until now.
3, 2, 1. That's about 2 ounces of white powder. That's just a rapid burn, zoomed in really close at a really awesome speed.
It's probably about 6 inches across.
Time Warp is turning its high-speed cameras on the show within the show. We start on the ground here at the Boston Fire Department Training Facility. We figure when you're playing with fireworks, it can't hurt to have an entire fire department and a dynamite-proof bunker right nearby.
Something just great about pyrotechnics. Twisting wires, rolling them back. All we need is a plunger and a Wile E. Coyote.
Fireworks for Dummies, Chapter 1. Pellets of black powder, color-coded chemicals, paper mache lit in the exact sequence equals amazing ooh and ah type explosions.
All right, here we go.
Okay.
This is gonna get a little hot. 3, 2, 1.
Chemicals like barium produce green.
My eyes are
cool.
burned out now.
Anybody want to see red?
Why not?
And strontium, red. But one problem, we're on the ground floor. We need to get them up where we can see them.
I've got some mortars here so we can really see how they do the work of getting it 1,000 feet in the air.
So we can launch the fireworks, but what about our cameras? The plucky Time Warp team went to work, building a giant tripod.
Hang on.
So what are you guys blowing up today?
Oh, look, it's a Boston Fire Chief. Well, hello, Chief.
What are we not blowing up today? Well, we just looked at how much explosive damage we can do with a firework from the black powder explosion. So I think now we're going to take a look at how much work that can do for us, accelerating a charge upward.
What could possibly go wrong? Remember the last time the Chief paid an on-site visit? The time we mixed boiling oil and water? Whoa. For obvious reasons, we did not get away without a lecture.
Every year there were accidents with fireworks, mostly the small commercial kind, firecrackers and sparklers. But even with these, even though they're more regulated, if people aren't extra careful, damages can happen.
How fast does this go when it's accelerating out of here?
A couple 100 feet per second.
Okay, so we're talking near bullet speeds. We're going to need to get, 5,000 frames a second or so to see this thing moving.
Ready? 5, 4, 3, 2, 1.
All right. That's great.
Was all the fuss worth it? See for yourself.
Look at that.
You cannot even see the ball once it leaves here. It's engulfed in this flame.
You can see the ball just being pushed by the gases.
It's an amazing thing when it's all contained. It really looks like you're just pushing this thing along a tube. As soon as the gas can actually escape, it goes much faster than it can push the ball.
There's one frame of the ball leaving right there.
This tube and the whole tube in general all kicks down.
Yes.
Now we know what you're saying. Where's the air burst? Patience. Patience, dear viewer. Matt Shea pre-rigged a loaded shell to a boom arm and raised it 20 feet, the same height as the camera on our super tripod. When the shell is detonated, our high-speed camera will be right there to catch all the action.
Blow something up, let's blow something up, let's blow something up.
Now, to the Time Warp Command Bunker.
All right, well, we'll see you after the blast.
Have fun. Enjoy.
And action.
5, 4, 3, 2, 1.
Wow, one got in here.
Yes, one did.
One got in here. Is it on fire still? Nope. Almost killed our sound man.
Well, at least it missed the fire chief. And we did get the shot.
I'm amazed that you were able to shoot one under the door. That was good.
And this is the one that went in our room.